Structure of the nuclear atom. Contrary to Dalton's atomic theory, atoms are divisible into electrons, protons, and neutrons. So we will look at how these subatomic particles came to be, who discovered them. The first experiment is the cathode ray tube, which is a glass tube with a sealed gas inside. When you apply a voltage across the electrodes, you get a glowing beam, which is called a cathode ray. The cathode ray traveled from cathode to anode, so these had to be negative particles because they were going towards the positive anode, and they became known as electrons by J.J. Thomson in 1897. Thomson discovered from this experiment the charge to mass ratio for an electron. E over m equals charge to mass. That's what this experiment determined. So here's what I want you to know about the experiments. Just a little bit about them. What they discovered, in this case they discovered electrons, and the name associated with electrons, J.J. Thomson. Don't worry about the dates. I'm just giving you those for reference. The oil drop experiment was performed by Robert Millikan, and from this experiment, Robert Millikan determined the charge for an electron, 1.6 times 10 to the negative 19th coulombs, and put this together with the cathode ray. We can get the mass of an electron, 9.1 times 10 to the negative 28th grams. Electrons are by far the smallest subatomic particle. The canal ray tube is similar to the cathode ray tube, except particles travel toward the cathode. The particles are traveling toward the negative cathode. So these particles had to be positive. They became known as protons by Eugene Goldstein in 1886. And protons are about 2,000 times larger than an electron. So again, for these experiments, know the name of the experiment, a little bit about it, what they discovered, which in this case is protons, and the person associated, which is Goldstein. I will show you a demonstration of the cathode ray and the canal ray in class so you get a better idea of what these two experiments look like. Neutrons weren't discovered until 1932. Again, don't worry about the dates, but as a reference, they were about 40 years later than protons and electrons. James Chadwick discovered the neutron. There is no experiment here. Neutrons have no charge, and all atoms are electrically neutral. So here's a chart comparing the three subatomic particles. Notice with the charge, electrons are exactly opposite of protons in terms of relative charge. So we say electrons have a negative charge, protons have a positive. Neutrons, by definition, are neutral, no charge. If you take a look at the actual masses, protons and neutrons are relatively the same mass. Electrons are much smaller, about 2,000 times smaller than protons and neutrons. So that's just for comparison purposes there. Okay, so now we have some models. We had Dalton's model, just an empty sphere. Then came J.J. Thomson, who discovered the electron, and he came up with the plum pudding model, which has electrons stuck in place like plum pudding. I like to think of it as a chocolate chip cookie, but the electrons don't move. They're stuck in place. And the positive charge is spread throughout. So there's no protons and there's no neutrons, but that positive charge from the protons is spread throughout the model. So that was Thomson's plum pudding model. The next model came from Ernest Rutherford in the gold foil experiment. And what he did was he shot alpha particles, which are positive particles, through atoms of gold foil. So if you think of atoms of gold foil, really close together. So here's my gold foil atoms. Most of these positive particles went straight through the atoms. You have some kind of detector over here that detects where they hit. But every now and again, a particle hit something in the gold foil and was deflected at a large angle. But 99.99% went straight through the gold foil. Just a few were deflected at large angles. So from this experiment, the gold foil experiment, Rutherford came up with his model for the atom. And he said most of the atom is empty space because most of the alpha particles went straight through the gold foil. So most of the atom's empty space. However, there has to be a tiny central core, which he called the nucleus, because every now and again, those alpha particles were deflected at large angles. So Rutherford came up with the idea of the nucleus, which we still hold today, which is the tiny core with protons and neutrons. So most of your mass is in the nucleus. All of your positive charge is in the nucleus because that's where the protons are. And then the electrons are simply floating around outside this nucleus.